David Kahn here with another question from your Hayes and Harris Math SL textbook. This is Chapter 19C.2, Question 2a. We're working with sine rule here, and this time we're trying to find an unknown angle in a triangle. We're given some information. We're told about little a and little b, and these will be the sides because they're given in centimeters. And we're given an angle ABC given in degrees. So let's sketch out this triangle. We'll have three sides, A, B, and C. And angle A is going to be opposite side A, angle B is going to be opposite side B, and angle C is going to be opposite side C. We're told the length of side A is 14.6, the length of side B is 17.4, and the angle ABC, so from A to B to C, that would be this angle here, is 65 degrees. And we're asked to find angle A. That's that angle. So we'll use sine rule because sine rule relates a side to its opposite angle given another side and its opposite angle. So we'll be able to say that the sine of angle A over side A is equal to the sine of angle B over side B. And if you notice, this is upside down to the way that I wrote the formula in the other section, and that's fine. You can flip it upside down if you want, and you can have angle over side equals angle over side, or you can have side over angle equals side over angle. You just can't mix and match and have angle over side equals side over angle. That doesn't work. As long as you're consistent within the problem, though, you can flip it around any way you want. So we'll plug in what we know. We want the sine of angle A, but we know side A, that's 14.6. We want the sine of angle B, so that's sine of 65 degrees, and we know the length of side B, that's 17.4. We'll rearrange this to solve for the sine of angle A, and that'll give us the sine of angle A is equal to, and by multiplying both sides by 14.6, we get 14.6 times the sine of 65 degrees over 17.4. Now, 65 degrees is not one of the major angles that we're supposed to have memorized, and so we'll have to turn to our calculator to solve this expression. Our calculator is going to tell us that it's approximately equal to 0.760 to three significant figures. But we're not done because we don't have angle A, we have the sine of angle A. To get angle A, we need the inverse trigonometric function, inverse sine of 0.760. Once again, this is not one of the major lengths on the unit circle, so we'll have to turn to our calculator again, and we'll find that angle A is 49.5 degrees if our calculator is in degree mode. But that's not necessarily the correct answer. We need to check this, because whenever you take an inverse trigonometric function, inverse sine, inverse cosine, inverse tangent, you need to check the unit circle and see if there are other possible solutions, because your calculator is only going to give you one, and it will not give you warnings that there are possible others. So, what we need to do is we need to draw out a unit circle and see what makes sense. So, what we want is the sine of, the inverse sine of 0.760. Since we're talking about sine, we're talking about a vertical displacement along the y-axis, and 0.760 is about 3/4 of the way to the top, which is 1. So there's half, split that into quarters, and we're about 3/4 of the way up. So we're wondering what angles have that vertical component. Well, we already found one. It was 49.5 degrees, has that same vertical component. There's another one, though. It's over here. It's going to be 180 minus 49.5, or 130.5 degrees. So 130.5 degrees is another possible solution for A. In fact, there are infinite solutions for A. We can go around and around and around again on this unit circle, so we can have 49.5 plus 360 plus 720, and so on and so forth. But the sum of all the angles in a triangle must be 180 degrees. And so A must be less than 180 degrees. If it's more than 180 degrees, then the sum of all the angles in the triangle won't be able to be equal to 180 degrees. And so we can throw away all of the solutions which go around and again, and we'll look at only 49.5 and 130.5. Now, like we said before, the sum of all the angles in the triangle must be 180 degrees, which means that angle A plus angle B plus angle C should be 180 degrees. But we already know angle B. Angle B was 65. And angle A we're proposing is maybe 130.5 degrees. If that's true, 130.5 and 65 together gives us 195.5, which is too big. It doesn't leave any room for angle C to sum up to 180 degrees. And so we can throw away 130.5 as a solution and leave only 49.5 as the only possible solution for angle A.